This is for 5.2 notes, polynomials, linear factors, and zeros. Part A is very similar to what we did earlier this week. It asks us to write the polynomial in standard form from highest degree to lowest degree. So as I look at this polynomial, I see the first one is degree 2, the next term has degree 1, the next term has degree 3, and the last one is degree 0, based on their exponents. So if I'm going to put these in standard form, I need to write it with the largest exponent first, the largest degree first. So the 3 goes with 6x to the third. Then the next one is 3x squared, and it's plus 3x squared because it's a positive 3. And then the 1, degree 1 goes with minus 5x, and degree 0 is plus 2. And so this is our standard form for this polynomial. Okay, so you can do numbers 2 and 3. Let's look at the segments part, part B. So in this section, the goal is to determine what kinds of zeros they have. How many are real zeros and how many are imaginary or complex zeros. So I'll write that instruction. How many real zeros and how many imaginary or complex zeros are there? Okay, so that's our goal. And imaginary and complex are two words that we can use for basically the same thing. They involve I. So if we look at number 4, the first thing I want to notice is that there is degree 4. That's the largest degree. So I am expecting to find 4 zeros. So there are 4 zeros. So the first thing, after identifying how many zeros there are, is to check for how many real zeros. How many times does the graph cross the x-axis? I see 1, 2, 3 places where it crosses the x-axis. So I know I have 3 real zeros, but there's 2 indicators here. One is that the imaginary or complex zeros always have to come in pairs, in groups of 2. And so since I already have 3 real zeros and I only have 4 zeros total, that leaves me with 1 extra zero. The other indicator is that this graph comes down and touches the x-axis but does not cross the x-axis. When it touches and turns around and goes back the same direction it came from, this is an indicator that there are 2 real zeros, that this number, 0, happens twice. So we have 4 zeros and all 4 are real. 4 real zeros. And sometimes you'll see this written in sort of braces. We see that we've got -1 is a 0, 0 is another one, and +2 is the third one. And we don't have to write 0 twice, but just know that -1, 0 is considered to be a double root. 0 is a double root. It means it happens twice. Okay, so what I'm looking for here is there are 4 real zeros. Okay, so using those ideas, problem number 5, I see this is x to the 3rd power. So that means I'm looking for 3 zeros. 3 zeros. And as I look on the graph, I see one place that it crosses the x-axis. And there's nothing different. It goes straight through that point, which means there is one real zero. Well, if there's only one real zero, that means the other 2 zeros must be imaginary or complex. 2 imaginary zeros. So one thing you can look for here is every time that the graph changes from going up to going down and back up, each time it changes directions is sort of an indicator that there is a zero. So this first part goes up, that segment of the graph has an imaginary zero because it does not cross the x-axis. This segment has another imaginary zero because it does not cross the x-axis. And this last segment, has one real zero because it does cross the x-axis. If we look back and see how that applies to this first graph, number 4, it goes up and it crosses the x-axis before it gets to that top point. So there's one real zero there. Then it comes down and touches, and so where it touches, that counts as a real zero. And then the next section where it goes up, again, where it touches at the very start of it, that counts for both of these two segments as one real zero. And then it comes down and crosses the x-axis, and there's our 4th real zero. So 1, 2, 3, 4. So if we look at number 6, we look at the equation. I see the degree is 5, so I'm looking for 5 zeros. So how many of those are real zeros? 1, 2, 3. Each one of those goes straight through the x-axis. It goes from one side right to the other side. So there are 3 real zeros. But we need 5 zeros total. That means there are 2 imaginary zeros. If we look at our segments, we've got one that does not cross the x-axis, so there's an imaginary zero. Comes back down, does not cross the x-axis, there's a second imaginary zero. Then it goes up, and it does cross the x-axis, so there's a real zero. When it comes back down, it crosses the x-axis, a second real zero. And finally goes up, crosses the x-axis for a 3rd real zero. So problem 7 and 8 have something just a little bit different about them. If you look at the equation in 7, we see 4, so we're looking for 4 zeros. As I look on the x-axis, I see 1, 2 points here. The first one goes straight through. See the segment that's going down till it gets to the bottom? It crosses the x-axis, goes straight through the x-axis, so there's one real zero. Now the whole rest of the way it's going up, but it's not a straight, smooth curve. There's changing of directions through here. And so in this case, when each time that it sort of changes directions, there's an additional zero in that place. And so when you see that it goes through the x-axis, but it does a little bit of a curve through there, that is so in this problem, this 1, 0 is a real zero, but it kind of goes straight through, but then it changes directions. And so there's sort of an extra segment in here where it went straight through and got a 0, but then this part and this part are kind of separate. And so we know that either we have to have 3 zeros through here, but it goes straight through. And so there's only one real zero, and the other two must be imaginary. So this ends up with 2 real zeros and 2 imaginary zeros. This type will perhaps make more sense once we can actually work with the equation a little bit more. Problem number 8, we're not given the equation, but as we look at this, we see one real zero here, one place where it crosses, but this graph comes up and it sort of flattens out, and for a second we don't know, is it going to come back down or is it going to go through, go back up? When you see this type of motion through in part of the graph, that is a sign that there are actually 3 zeros at that point. And so 0 occurs 3 times. It is a triple root in this case. And so this is the graph of y equals x to the 3rd power, where 0 is a triple root. A triple root. And so anytime that you see the graph flatten out right as it crosses the x-axis and then continues through, that's a sign that there are 3 of that real root, that real zero. So in this case we say there are 3 real zeros. Now, as I stop to think about it, sometimes this may get classified as having one real zero that happens 3 times. So it has 1 0 that is a triple root. Whereas back here in number 4, this has 3 real zeros where one of them is a double root. And so it's a little bit of a technicality. Don't worry about that too much, just realize that we can look at the graph to see real roots and look for pairs of imaginary roots or imaginary zeros.